Hello everyone, welcome to our talk on the paper capturing the content of documents through complex event identification. I am Zheng Qi from University of Pennsylvania. This is a joint work with Elior, Sulem, Haoyu, Wang, Xiaodong, and Roth. So given a long document, people are usually interested in capturing the content of this document, but the question is how. An intuitive solution is to extract all grammar events in the document that are instantiated by predicates, just like what is shown on the right. However, considering each grammar event in isolation is not sufficient to capture the content. For example, given a list of grammar events on the right, it's difficult to infer if did E2 chaos happen during E7 protest or E8 elections. Also, did E3 attack and E14 wouldn't happen in the same E7 protest? As you can see, many grammar events describe an instance of topic and could be grouped into more general events. These general events together capture the major content of the document. So in this paper, we propose the task of complex event identification, where complex events are defined to be the clusters of grammar events that describe a more general event. For example, in the document on the right, there are two complex events. The first one is the green one, that all grammar events describe what happened during the protest, while the red one is an election complex event, where all grammar events describe what happened in the election. Two characteristics of complex events are very important. So the first one is the sentences corresponding to the same complex event are not necessarily consecutive. As you can see, the sentences of the green one are separated by those of the red one. Second, the complex events are clusters of grammar events rather than sentences, so grammar events belonging to different complex events can appear in the same sentence. However, to identify complex events in the document, the notions of event-event relations and event region are quite limited. Temporal relations only consider the ordering in time of grammar events. Causality only considers if one grammar event contributes to the occurrence of another grammar event. Event coreference do denotes two grammar events refer to the same real-world event, but at a much fine-grained level. In the previous example, E2 killed and E14 wouldn't belong to the same complex event, but not co-referred. Sub-event relations denotes one grammar event spatio-temporally contains another grammar event, but the notion is still limited because, first, the scope of complex event depends on the existence of a high-level grammar event. For example, Billy Graham was released from hospital after recovering from pneumonia. Release and recovering do not spatio-temporally contain each other, but they belong to the same complex event. Second, a pair of event sub-event may not belong to the same complex event. For example, in this case, obviously race spatio-temporally contains turmoil, but they should belong to different complex events. In Chen's paper, they proposed the notion of event region, which is a byproduct of document-level argument extraction. They remove sentences that do not contain arguments and partition the text into several parts. They define these adjacent sentences as event regions. Since event regions have to be consecutive sentences that include relevant arguments, the scope of event regions is much constrained than complex events. So we present a context-augmented approach to directly identify complex events. The first step is to predict whether two grammar events belong to the same complex event. The issue here is whether they belong to the same complex event also depends on the context of the document. In the previous example, we know killed and wouldn't belong to the same protest complex event because the document only describes a single protest. However, if there are multiple protests in the document, it's difficult to infer if they belong to the same protest or not by just looking at these two grammar events only. So our solution is to add an additional context grammar event to help model the pairwise complex event relation. We first concatenate the sentences of two grammar events and use pre-trained language model Roberta to learn contextualized representations for each token in the sequence. Then we get the predicate representations by summing up the representations of predicate tokens. To select the context grammar event, we use the concatenation of two grammar event representations and the representations of other grammar events in the same document to compute the attention distribution, and select the one with the highest attention score as the context event. We also manually set an attention score threshold to guarantee that the context event is highly related to the two grammar events. If the highest attention score is lower than the threshold, we simply mask the context event with 0. Finally, we concatenate the representations of these three grammar events and forward it to an MLP to get the probability of belonging to the same complex event. After predicting the pairwise complex event relations, we use agglomerative clustering to cluster grammar events into complex events. The distance between two grammar events is defined to be the likelihood of not belonging to the same complex event. We merge event clusters until no cluster pairs have a linkage distance lower than the threshold. The linkage distance is defined as the average distance of all the event pairs across two clusters, and the threshold is fine-tuned on the left side. Finally, we regard each event cluster as a complex event. As for experiments, since there is not a dataset tailored to this task, we derive a working version of complex event annotation from Haoyu dataset, which annotates sub-event relations and event coreference. For each document, we build undirected acyclic graphs where vertices are grammar events and they are connected by sub-event relations as edges. We define grammar events in the same graph as belonging to the same complex event. The dataset statistics are shown at the bottom right. We compare our model with three baselines. The first baseline is a sequence classification model plus the clustering step, where the sequence classification model encodes concatenated sentences using Roberta and forwards the contextualized CLS token to a later layer to compute the probability. The second baseline is a strong predicate representation learning model plus the clustering step, which replaces the CLS token with the concatenation of two predicate representations. Since our complex event annotation is derived from the Haoyu dataset, which annotates sub-event relations, we also compare our model with Wang's joint constraint learning framework for extracting temporal coreference and sub-event relations, plus the clustering step. We use agglomerative clustering for the first two baselines that directly identify complex events, and for the third baseline, which extracts sub-event relations, we follow the same graph-based clustering method as building the dataset. So we present the experiment results here. Since complex events are clusters of grammar events, we use coreference evaluation metrics for evaluation, including MUC, B cube, CEF, sub E, blank, and colon F1. Colon F1 is the average of the first three metrics. As you can see, our context-augmented approach, context RL, outperforms all baselines with a colon F1 score of 80.31. We also show a document with complex event prediction. There are two complex events predicted. The green one is a filing complex event that describes a new case filed by a new lawyer for O.J. Simpson, while the red one is a crime complex event describing what O.J. Simpson might have done long ago. We further conduct an exploratory case study on the wiki event dataset by using complex event as inputs of document-level argument extraction. Arguments are usually scattered across sentences, and document is usually too long to fit into a transformer-based model, which limits the max sequence length. Since grammar events in the same complex events usually describe in the same general content, we assume the complex event should contain all the information required for the prediction of arguments of its grammar events. So we applied our complex event identification system that was trained on Haoyu dataset to identify complex event in the wiki event dataset, and use synthesis of the complex event as input for argument identification and classification. We found that the input is much shorter as the average number of words dropped from 787.9 to 539.25, but the performance is very close. We also show an attack runner event from the document which has the largest improvement on argument identification. As you can see, using complex event as context removes much irrelevant information, such as the intervals in the report. Arguments in green are correctly extracted, arguments in red are missing, and arguments in orange are extracted incorrectly. So in conclusion, we introduced the complex event identification task that allows one to group related granular events into complex events that together capture the major content of the document. We also show a context-augmented representation learning approach, context RL, tailored to the task, showing that this approach outperforms strong baselines. We further conduct an exploratory case study on the wiki events dataset, showing that using complex events as input for document-level argument extractions obtains more concise context and achieves similar performance. For future work, we plan to annotate a new complex event dataset from scratch with fine-grained guidelines and extend our approach towards an end-to-end system with granular event extraction. Thank you for your listening.